Hello there, ADC21. My name is Thorsten Sideb0ard, and this talk is REPL, a new interface for algorithmic music. I'm going to be speaking about and demonstrating software I've been working on for the past few years called Soundboard, or SB Shell. Let us fire it up. Move my webcam out the way. Okay. Yeah, so a soundboard is an interactive text-based interface for making music and a live programming language for controlling these instruments that we can create. It's a standard programming type language. We can assign to variables. It'd help if I could type. Standard things as you would expect. It has booleans, for loops, conditionals, first class functions, and yeah, let's see. So first class functions are pretty useful. Let's add 5. It's a function which takes a variable and it returns that variable with 5. Unsurprisingly, at 5 we can call this with our other variables. We can call it recursively. Nothing too out of the ordinary here. What is different from normal programming languages is that it has inbuilt instruments. A couple of different synthesizers. Subtractive synth based on a Minimoog. FM synth based on a DX100. Granular synth inspired by Robert Henke's Granulator 2 from Ableton. Let's create one of them. We'll create an FM synth. We'll call it DX. So FM is the command to create our FM synth. And we'll assign this to a variable called DX. And to see our way around this, very much based upon the sort of Unix interface as well. We have a command PS, which is process status from Unix, and it's very similar here. Run PS, we get our header. We have various information about the mixer itself, the volume we're running at, BPM we're running at. This is more informational. We can't change this. This is the loop length in MIDI ticks, which is pretty useful to know because we can program against that. And number of peers. This comes from Ableton Link, which is incorporated here, which means you can sort of jam with other versions of other copies of Soundboard running on the same network, or other people with Ableton Live. If you're on the same network and you both have Ableton Link enabled, Ableton Link uses multicast, and you can discover other users on the same network, and it will handle your BPM synchronization and your phase drift within that BPM itself. You'll see a number of different variables we've created here. We have our Y that we created, our X that we created, and our DX synth which we created. You will also notice these other variables which exist, and we didn't seem to create them. These are, as you can probably guess, these are rhythms. It's 16 steps, 16-step array with ones donating the onset of a hit. And beyond the variables, we will also see a proc down here, process, and I'll explain them more as we move along. But a process, basically, we can create and assign to these process slots a process which will run in the background. There's a program that we can create, and it will continue doing work. So we can now create a process which would be perhaps generating, playing the melody on a synth while we're busy programming something else. We'll get into all of that. Let's see. So we have our DX, and running PS here. We don't see too much information about this. We just see the volume, its pan setting, and the algorithm that's running. Info is a command where we can get a bit more. So we can run info DX here, and we can see this would be if you had a UI, graphical UI, or you were looking at a real synth, this is sort of more what you would see. The top part here with the voice section, which is your kind of overall control of the synth itself. We have algos. I'll go into that a bit more in detail in a second. We're running at algo 1. We have things like portamento, we have the pitch range, op4 feedback, legato, various different synthesizer options more. Now an FM synth, not the DX100, the architecture of it, has this concept of operators, and an operator is quite simple. It's basically an oscillator with its own envelope generator. So the operator 1 here, we have the wave shape of the actual oscillator itself set to a square wave, ratio and detuning, and the second line here is the envelope setting. So we have attack, decay, sustain, release, and we have 4 operators. And we have Lfo routing down here, the LFO. One LFO, which has 4 destination slots, can go to the amplitude modulation, or it can do vibrato, or none. And these 4 slots can be assigned to any of these different operators. Let me explain more about this algos. This is a diagram from a real DX100. Shows you here that 1 is so here's the 8 different algorithms which come with it, and what this refers to is the 4 different operators we have, and it's how these are all chained together. The top 4 algorithms here have 1 carrier, which is the operator 1. This is where the sound goes out, and the other operators are basically modulating the carrier frequency of operator 1. And so these are wrapped in various different methods. 1 to 4, actually I had an interesting page earlier which had a nice description. Algorithms 1, 2, 3, and 4. These are all single carrier algorithms providing the most complex FM modulation. They're best for pluck strings, guitar harp, bass, harpsichord, etc., hammered strings, reed wind instruments, woodwinds, and conventional synthesizer type voices. Algorithm 3 is a good choice for programming bowed strings as well as some horns and brass voices. Algorithm 5, you can see here that it's got this kind of dual, 1 and 3 are both on the bottom. So this one has this dual carrier algorithm, has 2 separate FM modulation stacks. This lets you create voices with 2 distinct voice elements. Goes on. Algorithm 6 has 3 carriers, all modulated at the same time by a single modulator. It is useful for brass, horns, etc. And algorithms 7 and 8, these have 3 and 4 carriers respectively. Both of these algorithms are best suited for creating smooth, gentle voices. And maybe I'm going to stick with just the current voice it's at. The preset is called Raver at the moment. And perhaps if we have time later, we can start adjusting some of these operators and getting some different voices from them. Now that we have the instrument, the most basic command is a note on, and you give it the instrument name, DX, and then you can give it a MIDI value which to play a note. Nice fat bass there. There's an inbuilt command here, MIDI ref, and this is more just informational. MIDI notes go from 0 to 127. Starting from C, that'd be exceptionally low C on 0. Middle C is one above here, it would be 60. This is just randomly octave 3. I just sort of chose one octave, and you can sort of see the range. And to go up or down from there, you can just to go up or down octave, you can just add or subtract 12 from them. Another piece of information for my own use here is chord progressions, and I think we'll actually use them soon as well. So yes, note on, we could do DX, we could give it C3 here, 48. 24 if we want to come down, middle C, quite high there. Yeah, let's start with, we can further adjust note on, we can give it a duration. I think the default is about 100, or maybe even a bit more. Longer tail on there, and we have velocity as well, so the default that I've got it set for is 127, so this should be the same. Just bring down that duration again. Velocity, you can play around with this, so like bring that lower, a bit quieter, etc, etc. And I mentioned the MIDI pulses. Once we actually start getting into programming, if you want to program over a bar as opposed to playing instantly, we have a note on at command, give it the MIDI note, and then you can actually give it a value of when it should play in MIDI ticks. 240 would be in 1/16 of a time, so there's a 1/16 of a gap there. Longer, you get the idea. Well, maybe you don't get the idea, but we'll have more demonstrations of that. So instruments and MIDI notes are our main vocabulary here. Now there are some other functions. Some of them are inbuilt, and some of them are just ones I programmed and I have stored for further use. Let's see the MIDI ref again. So let's start with this C3, MIDI value 48. There's an inbuilt command, notes in key. This could perhaps be called scale better. If you call it, we're going to call it with 48 here, and what this will do is give us back, we're passing in a root note here, so we're passing in C, so it's going to be in a C scale starting from C, and it's going to give us a major scale, so that's the 48, 50, 52, 53, 55, etc. There's another inbuilt command here which is play array, and you can basically, we give it our sound generator, we'll say notes in key, we'll give it that, and what this will do, play array will take in your array, there's 7 values here, it will space those 7 values evenly over a measure, so this will basically play our scale for us. Notes in key by default gives you back a major scale, that the default is a 0, this should give us the same. We can get back a minor scale with, and actually I really should add in a pentatonic, but that's not in there at the moment, but easy enough to add. So that gives us a scale, that's pretty good. We can also do notes in chord. If we want a C chord, we'll stick with this middle, or C3, and we can see here we get the C, we get the E, and we get the G. I just double check, yes, there we are, E 52 and G is 55, so we get a C chord, and we can note on also will accept an array, so we can pass in this value. We get a C chord, and we could do a minor. We can also do an augmented, and what that basically does is that's playing a 7th on top of that as well. I'll just show you that. So we actually get 4, 2 cats running around in the background here, probably going to knock over some, chasing each other. Yeah, we get, rather than the 3 notes in our chord, we actually get the augmented with the 4th, and that's on the 7th. What else do we have? Notes in key, notes in chord. They're the most useful ones I want to show at the moment. Now, what about rhythms? Now, we see these rhythms. That's one thing. And there's another inbuilt command here. What's let me remember them. Combiner. If we give it an array, let me see first. Play array dx, we'll say bossa. Now these are MIDI values that you want to be passing through, and the bossa is only 1s and 0s, so it's rather a bit low. Sounds alright, but it's still pretty low. This combiner is specifically for combining rhythms with notes. So we can pass in the rhythm, and say we wanted notes in key, what this will do, so we've seen that notes in key, if I can spell correctly, will give us back this array, and that's all just like a scale of C starting from C3. If we combine that with the rhythm, what it will do is walk through the rhythm, and it will replace those 1 values with values from the array you pass in. So rather than 1s, we get this, and that's more useful for a melody. Let's pass this into the play array. Wait, what's going on there? I guess that's still correct. Perhaps what we'd want maybe more is notes in chord. Cool. We can do that. And there are other rhythmic functions which are good. Let me see which ones. So there's something called, often called Euclidean Rhythms. And it's, the idea behind it is, there's a researcher, Bjorklund, who he had a project where he basically there's a number of radio slots and he had messages to pass through them. There's any number of slots and he had a number of messages. This is quite analogous to like a 16-step array, and you want those hits of a 1 being in there. Say we wanted 5 across 16. Gives you back an array of 16 lengths, and it puts in those 5s, and it uses an algorithm which is very similar to the Euclidean algorithm for finding the lowest common denominator. It'll basically start, kind of break them down. Like, the algorithm for this kind of is nice. Like, it gives you these rhythms which actually seem to work quite well. Let us create a drum rhythm as well. I'll create a drum kick here. Play array. BD Bjork 516. So, and there's another, we can do this other function, rand array, and you you say how long you want the rhythm or the array to be, and you can give it a low starting value and an upper value. By giving it 0 and 1, we can get something similar to a rhythm again. And this is just randomly selecting between them. So this can work sometimes. So we have a number of different things. We have the Bjorks. In fact, let's do the hi-hats again. I find that hi-hats sound good with a Bjork rhythm of 11/16. Combine that with our bass drum playing a Bjork of 5/8. So we have our Bjorks, we have a rand array, and there's actually a rand beat, which basically just return one of these 6 pre-created ones. So we have a number of different ways of getting rhythms. I mean, you can program any of these yourself, and once actually we'll get into opening a text file soon and see how we can program processes more. These are more, basically I'm walking through building blocks at the moment. So we know some stuff. We have our scales that we can use, or we can use chords. We can get the key. We can get the MIDI numbers for chords. We have a number of different ways we can get rhythms, and so there's a couple of inbuilt functions which combine some of these for us rather than us having to do it all the time. One of the main things here is the fact that anything you come up with, you can then save as another function and like build upon that. So one here is called Riff, and Riff, actually I think if I just show it here, it will create a beat. It will create one of these Bjork beats by taking a random number between I guess 2 and 11 here, around 9 plus 2, so you can get up to 11 over the 16 steps, and whichever root note you pass in here, it will just replace the one with your root note that you're passing in. So it's just going to give you like a single note rhythm, but we can do riff, let's take it to 20, and rather than ones we get back the 20s. Let's try and see how that sounds. Play array dx and we'll do riff 20. And we have a different key riff. You pass on your root again, and kind of similar to this is called key riff because it's the notes in key. It'll create this. In fact, if I show you again, key riff, it will take valid notes, which are notes in key, which we've seen earlier, and it'll just give you your scale back, and it'll do the same with the beat, and it will walk through, replace the beat with one of the notes from the key. So key riff 20. Let's see how that sounds. Play array dx key riff. And there's a third variation, which is a chord riff, which could maybe just be called a array riff. Basically, you give it an array rather than a single value for the root. So we could do notes in chord. I'll go for another C here, and so notes in chord 36. We get the 3 values. So basically this is just going to walk through and it's going to randomly select one of your values for your riff. This is good if you actually want to stay within a chord itself and just playing a pattern within that chord. Chord E riff notes and chord. It's getting a bit nested. Do I have enough brackets? Chord riff notes. Cool. So I think that's, let's see how we're doing on time here. 23 minutes. I think we've been through most of the building blocks. So we have our synths, we have our sample players. As I mentioned, there's granular synth and so, but I'm going to stick just with our, I'm going to stick with just our kick drum, our hi-hats, and our DX synth for the moment. So the next big thing to show is live coding. So let me talk about the processes again here. So I've created a new file, SB tracks ADC.SB. Over here we can monitor a file, ADC.SB, and anything, whenever we save this file, it will get reloaded over here. Let's create a generator. Now I kind of alluded to generators without explaining them earlier. A generator is very similar in concept to how the processing environment works, or Arduino if you've programmed any Arduino. And what they have is basically 2 internal functions. One is setup, which is called when it's first created, and so we can store state in here, and run gets called each time you call the generator. Run will get reevaluated each time, and so that is how we can. Well, let me give a demonstration of it. Run we shall play array hi-hats Bjork 11, 16. We'll kind of recreate what we had working there earlier. 5, 16. That should do for the moment. Okay, so now we should have access to this. We can run the command by itself. That sounds quite nice, actually. If we want that to continue running, we can assign it to a process slot. And the way we do that, the dollar denotes a particular form of process, and the dollar one basically means, actually hash and dollar are kind of similar. They used to have more of a distinction, which matters less these days. But basically we'll get called once on every loop, and that works. That's the generators are kind of designed for that, so we can assign the BLAGen to process slot 1. It's just going to keep going. It's not going to change anything for the moment, so I'll just disable that. Let us, we can change it up some. Let lens, we'll create an array here. We'll say 7, 9, 11. Give it an index. What we will do here is, instead of having that hard-coded 11, we will do lens LX, so it will start with 7. There's a function I wrote in here, and it is called increment, and it's just a standard increment, doesn't do anything you wouldn't expect, but you have a starting value, so LX is our starting value. It has a minimum value, which in this case is actually just 0. We want it to step through all these values, so it would start from 0, and it would go to len of lens, the length of the lens array, which is 3. So basically the increment will go from 0, 1, 2, as you would expect it will walk through. So basically what will happen here is that the hi-hat pattern will change on every loop. It will kind of iterate through, it'll loop through 7, 9, and 11. Alright, so let's do something with our, what else? Where can we go from here? So, play array, I've said, I haven't actually shown you too much of that, and we haven't used note on at. Let us, instead of using the play array, I'm going to show exactly what that does. Note on at BD. Now over here I showed you that PP is 240, which is the 3/40 divided by 16, so that's pulses per 16th note. Over here I'm going to do note on at, actually what I'm going to do is if, again, let beat equals Bjork 516. I'm going to delete this guy. We're basically going to recreate this manually. If beat I equals 1, we will do note on at 1, and the position is going to be I, that's 16th, times the pulses per. So we're going to walk through 16 steps. Our beat has 16 steps up here. If the beat has a 1, it will do note on at. It will sound generator, the value it's going to play. Now we also could make that beat I because it's a 1, but it's always going to be the 1. That's not going to change just because we're this is just a drum kick. And that I is going to be the position times the pulses per. I think I have a guest wanting to say hello here. Hello. It's Toty Bum. Okay, so we actually shouldn't notice any difference here. This should sound the same. let us do something. Let's add in the FM synth now. So MIDI ref shows us some of these chord progressions. 1, 4, 5, kind of simple pop punk chord progression. Let's use that. Let I equals what key should we go for? Let's, rather than using, to grab a pen and paper here, make sure I'm doing this. Let's go for a random key. Let's go for E, so 52, rather than staying with C all the time. So 52. That might actually be kind of high, so let's actually do 52 minus 24. So we'll go for 28. So we're going to be in the key of E. Key of E, 28. Right, watch out, cat. And let's see, so notes in key. Let's see if I can remember this correctly. So notes in key, there's our scale of E. So we have 28, 30, 32, 33, 35, 37, 39. Now these correspond to the chord progressions. So we have a major 1, we have a major 4, we have a major 5. So let's make I equals notes in chord. 1 is 28. And it's major, so we'll just stick with the default there. So like I, so I is that. Let 4 equals notes in chord, and that's 1, 2, 3, 4. We'll do 33. And we should do 5 notes in chord, 3, 4, 5, 35. So now we have 1, 4, 5. Let's get some riffs based upon. So that's the chords we want to use. How do we? Let's. Let I riff equals chord riff, and we're going to pass in I. Is this, am I correct here? I riff. Okay. Let's create our 4 riff. And our 5 riff. Let's see if that works as well. Good, good. Over here, let's do our order. So our riffs equals I riff, 4 riff, and 5 riff. And we need an index again, so we know which one of these riffs we're on. Now to start with, we should just do, I'll just do play array dx riffs rx, and then we shall increment it. Rf equals increment rx 0 len riffs. So it should play our first riff, our second riff, and our next riff. Now in fact, what if we want, let's repeat our I riff. So it plays twice, then it plays a 4, then a 5. Not the most. I mean, it's alright. We'll see how that goes. And maybe we just want that to happen every second time. So it's not just blaring the whole time. Okay, so let's change some other values in that. So I alluded to that there's other process types. So we have one process can run in here, and we're applying this generator to our process slot 1. Now there are other types. One thing which will change the sound of our DX synth is the attack here, and I'm going to use operator 1 because this is, if you remember our DX algorithms, we're on algo 1, and the one carrier for that is operator 1, and the rest of these all modulate that. But basically you can see our output values here. Operator 1 is the loudest one, and this is basically how much modulation is applied from each of these guys. Let's actually set, just so we can, let's just switch all of these off. So there's no modulation going on. Let's just see how that sounds. As I thought, there's not much modulation going on at the moment for that, so we'll leave them switched off, and we can start adjusting them more. But yes, the attack here set to 91 at the moment. That'll make a bit of a change if we change that. So here, process slot 2, and we're going to use this less than sign, which denotes a different type of process. And this one we're going to do like an oscillator process, and we'll say it should oscillate over 16 bars. It should go from the value of 10 to 91, and we're going to apply that to DX. One thing I didn't mention, all of these values here which you can read, you can change every one of them by this. This is a syntax. So set sound generator name, the variable name, which is DX, and then the name of the variable you actually want to change. So we're going to change the attack, and it's kind of coming like from C. We're just going to use this percentage sign, which will get switched out for the value where we're currently at between 10 and 91. We're not playing anything at the moment, so we shouldn't hear it. But if you look at the attack value here, it's going to keep changing, and it's going to basically oscillate between 10 and 91 over that time period of 16. So now, if we play Blajan, still getting back up to where it was. It still sounds similar. Start to hear it getting much shorter now. We can start. Okay, so it's P3. Let's try some other variations. So let's oscillate over 8. We'll change the value from the op2 to 90. So we expect this to start modulating more. And so that's ooh, where's it going there? It's starting to get a bit more nasty for sure. We're at 40 minutes. I'm going to call it at that, and any questions, feel free. Love to hear them. Thank you very much.